Hey, quick recap of yesterday. We looked at derivatives of derivatives. Right? You can do as many derivatives as you want, actually. That's higher order derivatives. And then we started applying it to applied settings. So we looked at simply a shape, and if the rate of change of the shape, if like a radius or height or something is changing. And then we looked at position, velocity, and acceleration, and how those are related. And so here it is. Oh, the overall, now there's displacement, speed, yes, but the overall thing from this position function, you do a derivative. That gives you your velocity function. You do a derivative. That gives you your acceleration function. And that's the relationship between those there. Okay, so we did this one. First example, right? Let's do another one. And then I want to show you a falling body example, which I'll explain what that is in a minute. But this is going to be the same type as the last one. So this is right down the bottom of page 13. Yeah. Let's see. So it's a point going up back and forth along this line. I'll draw it by curving it. But let's just say I don't know what it is yet. But maybe it starts here and it goes like this. Okay, something like that. It's really not curving, so I'm just going along here, but we do it like this, so we can see what it looks like. Okay, here we go. The difference between this one, I ask a few different things, but it also is a degree of 3. It's cute. All right, so here we go. First question, based on this function, modeling that point. When is the velocity 0? So when is time? Okay. Part of this is just knowing what it's asking for, right? I need a time. The velocity is 0. This is similar. It's worded slightly differently, but we did this actually yesterday. When the velocity is 0, so if I'm moving forward a couple steps and then I go to move backwards a couple steps, my velocity was 0 when I was changing direction. So in this one, when is the velocity 0? Well, we need the velocity function. I need the velocity function. And I can do that, it's the derivative of position. So I'm doing the derivative here. 3t power rule. 3t squared. Another power rule will be negative 24t. And then plus 36. And then 0. It says, when is the velocity 0? Well, they're telling us v is 0. They're telling us the velocity is 0. I'm going to put in 0. I'm setting this equal to 0. I'm not putting it in for t. The whole left side is 0. And I'll solve. I'm going to need a little more room, so I might erase this. So I'm setting my equation equal to 0, and I'm going to go ahead and factor and solve. Now on this one I can factor out a 3. GCF. So I get t squared, divide 24 by 3, I'll have the negative 8t, and then plus 12. Now I can factor the trinomial. I attempt to, and it will work. It won't always work. But if it didn't work, you do quadratic formula. It does work though. Negative 2 and negative 6. So from this one, t minus 2, we get t equals 2. From t minus 6, we get t equals 6. What about from this 3?
0.
It doesn't give us anything. Now, you're thinking of if it was 0, if there was like 3t, like this, then it gives us 0. Yeah, so actually I have students who will, yeah, big difference here. This one, I mean, you set 0 equal to 3, and that doesn't give you anything. In this one, you would set 0 equal to 3t and divide by 3, you get 0. All right, so this one just doesn't, it's nothing, it doesn't give us anything. So 2 seconds and 6 seconds. that is when the velocity is 0. In other words, probably when it's changing direction. I'll show you later in the year how we'll know that for sure. But probably going to be changing direction. We found the time, that's what they wanted. When is the velocity 0? Let's do the next one. When is the velocity positive? It's along the same lines as this one. They just want the same thing, right? But instead of it being 0, they want when that function, which we already factored and everything over there. I could have written that. I could have written this form. When is that function greater than 0? Okay, now to do this, this is algebra 2. We have not reviewed this year. I don't think you did it in pre-calc. Solving an inequality, a quadratic inequality. Solving a quadratic inequality. Here's what you do. You solve it as if it was equal to 0, which we already did, 2 and 6. Right? You then have to do, so it's not going to be positive at just one time, like 2 and 6. It's going to be a range of values. So what we're going to do is we're going to make a number line with 2 and 6. And we're going to try some values between 2 and 6 on the right of 6 and the left of 2. And we're just going to see, is it positive there or negative? And basically, like, let's say I try 4. If I get a positive, that means all of these are going to have the same value. They're all going to be positive as well. If I get a negative, all the ones in that range will be as well. And then I'll try like 7. And if they're all negative here, then everything to the right of 6 will be negative as well. Okay, so hopefully it starts to look a little familiar as we do it, but this was definitely, it's been a while, algebra 2, when you would have done this. Looks like I threw that. All right, so I'm going to try, let's pick some values. I'm going to pick 4. You can pick 3 or 5, doesn't really matter. I'm going to pick 7. It's the number on the right of 6. These are test values. I'm going to pick 0. Number on the left of 2. You pick 1 if you want. 0 is always very easy to plug in, though. I'm plugging these in to see, is the velocity positive or negative? And this is the velocity function. Or you could do the factored form if you want. I'm just going to do the original. I plug in my test values. Plug in 0 for t. 0 here, be 0. 0 here, 0. Positive 36. All I'm going to write down is a positive there. So what that means is everything, this is what we wanted. Everything to the left of 2, yep, that's what we want. Positive. Okay, I try out 4. So I put in 4 now for t. I'd like to not take too much time on this because it's just a calculation where you could 4 squared times 3 minus 24 times 4 plus 36. When you do calculator, or if you work it out by hand, either way, you would get a negative value. And so everything in here would be a negative velocity. That's not what we want. We then plug in 7 for t. So we're going back here, plug in 7. Again, I don't want to take the time, but you plug this in and work that out, and it would be a positive number. So everything to the right of 6 is good. So again, this is going to be a range of values. I'm going to write an interval notation. Okay, so when is velocity positive? These are test values. You're done with the 0, the 4, and the 7. I'm just looking at the 2 and the 6. Everything to the left of 2 seconds was good. Now, normally I would write that as negative infinity to 2, but time, we're going to say it stops at 0, or starts at 0, right? So I'm not going to say anything to the left of 0. So I'm going to say 0 up to 2. Again, if it wasn't an applied problem, you would say negative infinity to 2. And then nothing between 2 and 6, but then 6 to infinity is good. So I'll say 6 and on. Yeah, this is interval notation, 6 to infinity. That's the answer for part B. Goes directly from part A. A got us those key values, 2 and 6. Then we have to set up a number line with those to see where it's actually greater than 0. If it said, what is the velocity? Negative it would be from 2 to 6. So actually, let me finish this one up. It's actually not too much to finish up. So part C, when is the point moving to the left? In other words, moving velocity left, in this case, implies negative. This is the opposite of question B. This is worded differently. Basically, when is the velocity negative? Yeah, we after doing part B, we already did it. This was the negative. Between 2 and 6. That's interval notation, 2 to 6. And finally, when is the acceleration negative? The acceleration, we haven't done it yet, but it's the derivative of velocity. So let's see. So that under the derivative of the velocity, 3t squared 1. So it's 6t, and the negative 24t is negative 24. Okay, now this one, they want to find not when it's 0, but when it's negative, less than 0. This is not a quadratic, right? So on these, it's linear, just an x or t. You do just directly set it less than 0. Let me say this, if you wanted to do a number line, that would actually work on this one too. So you could, but it's much easier on these. Just solve it as a normal equation, but less than 0. So I'll add 24, and then divide by 6, and so it's 4. That's set builder notation for writing the answer. Interval notation would be, well, interval notation would be 0 to 4, because again, time we're not saying is not negative. So it starts at 0. Otherwise, it would be negative infinity to 4. Okay, so anything else I can clarify or answer on that one? There's one other thing I was going to say about it. Yeah, I think it was just, again, if the number line would work, like you could do 4 and plug a number in here on each side of 4. Oh, I know what I was going to say. If you're solving these, remember if it was like negative 6t, and you divide it by negative, do you remember you have to switch the sign to a positive when dividing with less than or greater than. Okay, let's move on to the next one. So different type. It's going to have a lot of the same words, velocity, acceleration, and all that. These were, here's a coordinate moving along the line. I love these, falling body problems. They're basically parabolas. It could be something starting on the ground and then modeling parabola. It could be somebody standing here and they throw something, or models like that. It could be somebody's on a cliff or a roof or something, and they drop something or they throw something like that. So basically, it's parabolic motion, and I'm sure you did that a little bit in algebra too. But now with calculus, we can do a lot more with it. So let's go back here. Okay. If you were in or are currently in physics, you probably already recognize the following formulas I'm going to show you here. These formulas were developed for these types of questions because acceleration, basically gravity, near the Earth, is constant. So if you are near the Earth, the gravity is acting on you at 32 feet per second squared, or in meters, 9.8 meters per second squared. Do those values sound familiar? If you were in physics. So what we can actually do, and I'll show you how to do this later in the year, is you can develop a formula that just based on this, that models these types of questions. It's pretty cool. We don't have the tools to do it now, but I'll tell you what the general formula is. It's this. Again, I'll talk about it later, but the general equation is this. This one is in feet. Let's go ahead and write down the corresponding one in meters as well. But basically, you got negative 16t squared this is position based on time for these, plus your v sub 0 is your initial velocity, let's say right here, times time, plus your initial height. S sub 0 is initial height. I want to write down the corresponding one. If it was in meters, it would be S of t equals negative 4.9 t squared, plus your initial velocity times time, plus your initial height. So it's the same thing, but negative 4.9. These are just ones that you start. We're actually going to write an equation based on what we know, but these are the formulas for now with what we start with for position. And again, if you were in maybe science, like physics class, you might recognize those. Anything to add? Any initial questions before we try one? Okay, so let's look at one. And again, it's just here's an equation we'll start with, and we're going to develop it, and then we'll answer some questions on it. So this is a rocket. It's being propelled straight up off the ground with an initial velocity of 160. Now, even though it says straight up off the ground, so it's going up and down, we're going to model it time. This is time. So it'll look right something like that. Abby, can you shut the door, please? So let's write a function. This one, what did I do? It said feet. So this will be this one here. Thank you. So I'm doing this one here. S of t is equal to negative 16t squared plus your initial velocity, v sub 0. Your initial velocity is 160 times t time plus your initial height, S sub 0, which is what? 0, because we're on the ground. So there was no initial height. So that's the equation. Okay, so that's it. Based on that, we'll do the other parts of the question. First one, find the maximum height of the rocket. So the height is the position. I'm going to write S of t. Okay, so height is position. So the maximum height would be here on my diagram. So to answer this, we got to kind of do something else first. What would be the velocity at the very top, just instantaneously? What's that below? I didn't mean to write it down, and then I kind of wrote it and asked. I meant to ask you what it was, and then have you answer. Okay. The velocity at the top is 0. Just it's going up, but it's slowing down instantaneously just for split seconds, 0, and then it comes down. So what we can do is we can find when the velocity is 0. I will do the velocity function by getting the derivative. So derivative here, negative 32t, and here, positive 160. Okay, now what we know at the maximum height, the velocity is 0. I'm not plugging in 0 for time. I know the velocity is 0. I think it's worded, oh no, when is the velocity? Yeah. So this one, it goes along with the last one we did, part B, part A. Part A in the last one. So we said it equals 0. And we solve? Yeah, I can oh no, I can just add 32t to both sides. So here, it's the 0 equals negative 32t plus 160. So we're going to add 32t to both sides and divide by 32, and we'll get 5. Okay, seconds. 5 seconds. So it says find the maximum height. That's not the maximum height. But that is the time when the maximum height occurs. So if I just arrow down here, this would be at 5 seconds. So what I need to do to finish up, I have the time, and if I want the height or the position, I just put in 5 for t. So really, I need to do, I'm going to do it over here, S of 5. position at 5 seconds. Negative 16, 5 squared plus 160 times 5. 5 squared is 25 times negative 16, negative 400. 1 plus 160 times 5 is 800. And so we get 400. This was feet. So that one, you kind of got to go a little bit around. You can't answer it directly at first. So I don't actually know the height, but I know that the velocity at max mic is 0. So you do the velocity, you set it equal to 0, and you get 5 seconds. Then you plug that into position. Okay, let me stop there for a second, and then I'll do C through E, go together a little more. Any thoughts on A or B? Yeah, that's fine. Thanks. Any thoughts A or B? So let's go look at C. Find the velocity of the rocket at a height of 256 feet. Find the velocity. They're asking for B. Height of 256, in other words, that's position. So they're telling you the height is 256 feet. Let me write down my position function again. Negative 16 t squared plus 162. So they're telling us the height is 256. This is the position or height. This whole thing. So I'm going to put 256 in. He's putting 256 in, and I'm going to solve. To solve this one, it's quadratic. I'm going to subtract 256 from both sides. So we get negative 16t squared plus 160t minus 256. I try to factor first, and I can at least do a GCF for negative 16. I get t squared. Here when I divide by negative 16, I'll get negative 10t. And then negative 256 divided by negative 16 is positive 16. Okay, and I attempt to factor 16 and multiply, I get negative 10. It will work. Not 4, negative 8, negative 2. They add to get negative 10, they multiply to get positive 16. Okay. So, I'm going to go down here. Part D doesn't take much space at all. So, remember, this one doesn't give you anything, right? It's just negative 16 equal to 0. That doesn't give you any solutions. This one does, it's 2 seconds, and this one does, it's 8 seconds. Okay, and again, this is not the answer. It is time when the height is 256. So if we want the velocity at these times, oh, and here I'm gonna draw my picture. So this is like 2 seconds here, corresponds to like right there, and 8 seconds right there. So yeah, it makes sense. It's gonna reach a height of 256 twice, right? This is 256, and this is 400. It's gonna hit it twice. Once on the way up, once on the way down. Okay, so last thing we need to do is plug in 2 to the velocity, which was this, and we'll plug in 8. So I'm going to write V of 2, right? We're plugging in 2 for 2. So I'm just going to kind of work it out up here. 2 times negative 32 is negative 64. Plus 160 will be 96. This is feet per second. Well, it's reaching a height of 400 feet, so. But you're right, it is pretty quick. But then gravity acts on it quickly as well. Oh, then v of 8. So we plug in 8 up there. So it's now 8 times negative 32 plus 160. You're going to get negative 96 feet per second. And this also makes sense. On the way up, it's got to be positive, the velocity. On the way down, velocity can be negative. And that makes sense, it would be. Okay. So then, so again, that was another one where you kind of had to, what do we know? Height 256. Kind of got to work backwards a little bit. Use that, find the time that's 256, and then plug in velocity. Let's finish up D. Find the acceleration of the rocket at t equals 7. We didn't even do the acceleration yet. It is the derivative of velocity, the derivative of the negative 32t plus 160. Derivative of that, just negative 32. So the acceleration of the rocket at t equals 7 is negative 32, because it always is. Feet per second squared. I could have answered this question first, guys, without even doing any work, because for these, remember at the top, these are near Earth problems, the acceleration for these for an object is just the gravity, just constant gravity. Last one, how long was the rocket in the air? Okay, how long was the rocket in the air? So it's asking for time. How long? Time. How long was the rocket in the air? Well, the thing we know, we're trying to figure out all of this, it's finally not in the air right here. Right at the end. What's the position here? What's the height here? 0. Same thing. Same thing. I was like, I bet it's because I said position. The position and the height are the same thing. That's just position function is the height function. All right, so the position or the height is 0. And so what we're going to do is plug in 0 for the position. And we can solve that and get the time. So let's go to the bottom. 0 equals, I had negative 16t squared plus the 160t. You see right here, that's something we know is true. The height is 0 when it's not in the air anymore. When we solve this, and it will get us t. Factor out a negative 16, 16t. And we'll be left with t on the first one. Divide this one by negative 16t, and we'll have 10. Negative 10. This is a t. Okay, so then this one right here will give us 10. 10 seconds. And this one right here, this is the one you were saying will give us 0. That's a t stuff. That doesn't look good. So really what you're doing is setting negative 16t equals 0. We're dividing by negative 16. And you get t equals 0 over negative 16, which is 0. So those are the two, and that should make sense. It's 0 seconds, it's on the ground, position 0, and after 10 seconds. And so 10 seconds is our answer. It's back on the ground after 10 seconds. All right, so falling body problem. We were able to set up the equation, answer some problems about it. You see, sometimes you got to work, not directly, kind of work backwards from something. Anything I can answer on that one? Okay. I would like to finish up with one more. So next page, last one. Yeah, the one with Ned. So we'll finish. This will be the last one we'll finish up with. And if it's time tomorrow, I might do a little bit of some business economics applications. Okay, so the difference in this one is two things. One is Ned is standing on a building. I draw a picture. It's not great, I know. I do my best. Ned is standing on a building. I should be a little bit more clear. His height is included in that. So, because if this was 160, then Ned's like 6 feet tall. You'd have to add them together for the total height. We're just including the 160 as all this. If it was a test or something, I'd make sure you weren't clear about that. So all this is 160. He throws a ball upward off the building. So I think this is what I want to talk about. I guess it's not too different from the last one. There was an initial velocity. Here's what I want to say. He's throwing the ball upward, so it looks like this. If he throws the ball upward, initial velocity, then it's positive. If it had said he throws the ball downward with an initial velocity, then it would have been negative. It won't tell you negative 64, but it would be. And then if he had dropped the ball, the initial velocity would be 0. And they wouldn't tell you that either. They just say he dropped the ball. Well, you should know the initial velocity is 0. So let's write our equation in that. I'm just going off the same form. This one is also form. So I'm going with the same formula as last time. It starts with negative 16t squared plus your initial velocity times time. And it is positive 64 because it's going up. It says it throws the ball upward. Plus your initial height. So here's the difference in this one. We do have an initial height around 160 feet. All right. Write a function to model position of the ball. There it is. I was going off the one from the last page. Well, CB, find the maximum height. This one should look familiar. The other two look slightly different, but this one should look pretty similar. Maximum height, right there, is when the velocity is 0. So they're asking for height or position. But we have to work backwards. We need to get the velocity, find the time that the height is at its maximum, and then we can find the actual height. So the derivative here for velocity is negative 32t and then plus 64. What else the max ball? So then we know the velocity here is 0. So I'm setting the velocity, the left side of the equation, equal to 0. That's a 4. I add 32t to both sides. You get 32t equals 64. And we divide by 32, and we'll get 2. So 2 seconds. So right here would be at 2 seconds. Finally, find the maximum height. So we plug in 2, because this is a function. We can get the height as long as we have the time. So now I plug in 2 for time. So really I'll write this. It's s of 2. Find the position after 2 seconds. Okay, so here. Order of operations. 2 squared is 4. Times negative 16 is negative 64. Plus 2 times 64 is 128. And then plus 160. When you add those together, 224 feet. Hey, by the way, notice this one is not symmetrical. The last one actually was. If I can go back. This one actually ended up being symmetrical. Starts here, lands here, halfway through, it's going to be at its maximum height. So, A or B? That's it. Yeah, any thoughts on A or B? C and D. So let's look at C. Find when the ball hits the ground. This one's a little more clear. We did a similar one in the last one, but find when, so what time, the ball hits the ground. That's when the position is equal to 0, position or height. And so we go back and we set our original position function up here equal to 0. So I'm putting 0 in for this whole thing. T plus 160. So setting my original position equal to 0. Let's see, factor out a negative 16. T squared, it'll be negative 16 into 64 will be negative 4 with the t. And then 160 divided by negative 16 is negative 10. Now, factoring here, 1 and 10 wouldn't work, and 2 and 5 don't work either. So we do have to do quantitative formula. My A is 1, my B is negative 4, and my C is negative 10. And I will, this will be good, I'll work this one out. So it's negative B, so it's negative 4, positive 4. Plus or minus the square root of b squared. Negative 4 is b, so squaring that would be 16. Minus 4, and then a is 1, and c is negative 10. All over 2a, and 2 times 1 is 2. So if I simplify what's under the square root here, this will be 16, and then negative 4 times negative 10 is, and 1 is positive 40. Right, just negative 4 times negative 10, positive 40. Oh, I forgot the 16, I'm sorry. I forgot to write 16. 16, or maybe I erased it. I don't know. Oh, here it is. I know what I was doing. I was writing it up here. It's 16, and then negative 4 to negative 10 is positive 40. So then when we add those, it's 56. That's fine. That's it right there. We can put in our calculator, and we'll get 2 different answers. So this is t equals these 2 times. Optional, you could reduce the square root. And then the 2 here and that one will cancel. I can't cancel the 2 and the 4. But if you reduce the square root of 56, it would. Or you can just directly enter your calculator. Now what's going to happen is if I look at my drawing up here, this one's going to be like this. If this was here, one of these solutions is going to be negative. It's over here. I only want the positive one. I want this one when it hits the ground. So actually the negative version we don't want because it would make the whole thing negative, which we can't have a negative time. But the positive one does work. When you put that in your calculator, it should be about 5.74 seconds. Last one. Any thoughts on C? Similar to the one we just did, but it does have quadratic formula. That was the difference. Find the speed and acceleration when the ball hits the ground. Well, we just found it hits the ground. The position would be 0, and it's at a time of about 5.74 seconds. Those are the 2 things we know. Position would be 0, time about 5.74. Let me start with acceleration. Acceleration, again, this could have been the first one I answered. Acceleration is constant near the Earth. You could do the derivative of velocity, if you forget. You do the derivative of the velocity one, where we had it up in part B. negative 32t plus 64. You do the derivative, it's negative 32. Constant. Feet per second squared. That answers that one. Okay, and find the speed. Speed is just the velocity. Okay, it's the velocity, but it's speed is always positive. It's the same as velocity, but if you get a negative, it's changed to positive. So basically, find the speed when it hits the ground. Well, we can do our velocity at the time it hits the ground, and then if it's negative, we'll change it to positive. So I'm doing velocity at 5.74, right? V of 5.74. So I'm putting 5.74 into my velocity equation here. So it's negative 32 times 5.74 plus the 64. Again, it's not exactly 5.74. You should leave it in your calculator as 5.74. It keeps going. That way you round it a little bit. Did you get it? Did you get some?
I don't know what's for mine.
Yeah, 119, you got 6, 8. See, I got 7.3. Negative 119.73. Feet per second. Now that's the velocity. So to answer the question, the speed is going to be positive 119.73. Oh, I was right in meters. Feet per second. Speed is always going to be positive.